Assalamualaikum. In this video, we will be doing project presentation for our project, which is pedestrian face and mask detection. Our group member consists of me, Muhammad Mustaqim bin Mazlan, NurNasuha Binti Amar, and Nurlena Binti Muntasil. So for our introduction, as far as we all know, we are currently facing the coronavirus or COVID-19 pandemic that is causing a global health crisis. One of the main or effective protection methods is for us to wearing a face mask, especially in public areas, according to World Health Organization. So in this project, we are proposing a simplified approach by using a machine learning packages such as TensorFlow, Keras, OpenCV, and histogram of gradient or HOG for pedestrian detection. So our proposed method is to detect a face from image or video, and then it identifies if they are wearing a mask or not, and also counting the number of pedestrians present in the place. So far, the method attains accuracy up to 70%.
Okay, next, methods and materials or tools which implement in this project. Our methods consist of two distinct phases, which are phase 1 by training the face mask detector, and phase 2 deploying face mask and pedestrian detector. Okay, next, methods and materials or tools which implement in this project. Our methods consist of two distinct phases, which are phase 1 by training the face mask detector, and phase 2 deploying face mask and pedestrian detector. In phase 1, firstly, file up positive and negative images in a folder respectively. Next, we have to run the train mask detector Python file to train the input dataset using TensorFlow or Keras. For further explanation, this will be explained later in the computer programs section. For phase 2, execute the detect mask video Python file. This file responsible for the face detection based on ROI to compute the bounding box location of the pedestrian with mask and without the mask in the video displayed. The green face bounding box will indicate that the pedestrian is wearing a mask, whereas the red bounding box indicates the pedestrian is not wearing a mask. Also, in the output video detection, it also states the status of detection, is it detecting or not, calculating the total pedestrian and the percentage accuracy of the detection.
And for the materials or tools, we are using the Python, a high-level programming language that is widely used currently, as well as the OpenCV, which is an open source library that we can use inside the Python programming language. And then for TensorFlow and Keras, we are using it for the machine learning purpose. So TensorFlow is an end-to-end open source platform for machine learning. It is a comprehensive and flexible ecosystem of tools, libraries, and other resources that provide workflows. And next is Keras. It is a high-level neural networks library that is running on top of the TensorFlow, CNTK, and Theano. So we are going to be using these two along with Python and OpenCV to produce machine learning or deep learning purpose.
These are our datasets, which comprises of 48 positive images with people wearing a mask and 48 negative images with people not wearing a mask. These datasets is important to train the face mask detector. The bigger the number of datasets, the better the accuracy of the detection.
Okay, we're moving on to the computer programs. So what we're going to do first is to create a Python file, which is train_mask_detector. So in this Python file, we will use it to train the images, which contain the positive and negative images. So first of all, we will need to import all the necessary packages. such as the TensorFlow Keras layers, the optimizers, application and such. And then also we import image utilities, matplotlib, numpy for mathematical calculation, and also argument parse and OS. And the second one is to construct and parse argument, and then we define the parameters. And then the fourth one is to load and pre-process training data, so that you load the input images and process it. And then the fifth one, we encode the labels, partition the dataset, and prepare for data augmentation. And the sixth one is to prepare mobile net V2 for fine-tuning of the images. The seventh one is to compile and train the face mask detector network. And then once it is compiled and trained, it will be used to evaluate the resulting model on the test set. And then the last one, it will plot the accuracy and loss curves of the train set.
Another Python file we use in this project is detect_mask_video. First, we import necessary packages. Then, define HOG and detect and predict mask function for pedestrian detection and face detection respectively. Next, it loops over the face detection and add face based on ROI to the corresponding list. It runs the faces through mask predictor. Next, construct the argument parser and pass the argument when launch the script in terminal. Initialize face detector, face mask detector, and argument to find the path to the video file. It loops over frames in the specified video file and detect people in the image and returns the bounding boxes for the detected objects. Next, it annotates the face mask detection results and it displays the results and perform the cleanup.
So to display the result or to use the executed or the train sets, we use the command Python and then the Python file, which is detect_mask_video.py, and then /video for the video that we want to use, and then dash output. So it will save the output as, so in this case it will save as output.mp4. So on the right side you can see that there's this image. It is one of the image taken from the video. So the image shows that it is able to detect 3 persons, and also it is able to detect a person that has no mask. So at the very least it is able to identify that there's a person that is not wearing a mask. So from this command that is executed, it is loading all the train set. So you load all the face detection and then face mask detection. So once it is executed, and this is the result that has been made. So we're moving on to the result. This is another result that we obtained. So the first video on the left, it is able to detect a few pedestrians, and on the 2 person on the front, it is able to detect this person wearing a mask and the person behind her not wearing a mask. So for the person that is a bit further behind them, it is a bit unable to detect if they are wearing a mask or not, probably because the size is quite small. And then on the right side of the image, it is able to identify a few of them. So 3 of them is not wearing a mask and 2 of them is wearing a mask. It is quite able to detect them since it is just blurred, but still able to identify that it is a face, and so it is able to also identify if they are wearing a mask or not. Okay, so from the results that we have obtained, It revealed that our algorithms manage to identify persons or pedestrians whether they are wearing a mask or not wearing one. So from two previous figures, it able to recognize a few of them, and also for the later one, it's able to also mark a few of them that they are wearing a mask or not. So this indicate that uh, to recognize pedestrian face using a mask or not by using computer vision and deep learning, the objective is achieved. However, there are still information or some problems that we can still improve, such as the amount of pedestrian that we want to detect, as well as detection for the face, such as from a bit further away from the camera. So the main reason that we can conclude is probably because of the amount of data set trained. So we could probably use more data set so that the false mistake, a false positive, can be reduced further. In conclusion, our project of pedestrian face and mask detection is accomplished successfully by using a computer vision and deep learning tool, which is Python, OpenCV, histogram of gradient, TensorFlow, and Keras. The findings also show that it is fairly able to identify a number of pedestrians as well as a pedestrian that is wearing a mask or not wearing one.
Okay, now we have done with the intro. Now let's proceed to demonstration to this project. As we have mentioned earlier, this project consists of two phases. First is training, the face mask detector, and second is deployment of the face mask and pedestrian detection. We have collected almost 50 datasets for each type, which is faces with mask and faces without mask. You can see the dataset here. Before, we have tried to train hundreds of datasets, but because the training takes a lot of time, so we reduce them to smoothen the training process. Next, we have this example folder, where in this folder contain the images we use for the detections. Okay, now let's review first the Python script to train the algorithm. First, we import the necessary packages, and then we construct the argument parser to parse the argument when we want to run the script. Here, we define the deep learning hyperparameters. This is initial learning rate, epochs, or the number of passes of entire training dataset the algorithm has completed, and last, the batch size. After that, we load and pre-process the training data, and then we partition the dataset for the data augmentation. Next, we prepare mobile net version 2 for fine-tuning, which means this will make small adjustments to process to achieve the desired output. Lastly, we will compile all train our face detector network. Okay, now let's see how we train the code. Firstly, we have to enter the virtual environments, and then we change the directory where this project is saved. Enter the command. And now the training is started. Okay, now the training is done. Let's see the second script for the deployment of face mask detector. So there are two codes. First is for the image detection and second one is for video detection. So first let's see the image detection. So these are the codes. We import all the necessary package, construct the argument parcel, when to run the command, and this one hop is to detect the person inside an image, and then we load the serialized face detector model. From this we will look over detection. So let's see and run the code. Okay, so this is the output. You can see that for face mask detection, it's able to detect accurately whether the person is wearing a mask or not. But for pedestrian detections, it is quite faulty. So now let's see the second script for video. So these are the codes. See how the codes work. Okay, so these are the output for the video part. Okay, so you can see from the demonstrations that the face detection is quite accurate, and for the pedestrian detections is not so accurate. So that's all for our presentation and demonstration. Thank you.